Okay, so the purpose of this video series is going to be looking at different type of player inputs. We're going to use a few keyboard ones, but it's easy enough to change, modify for a controller. It's looking at the principles of checking for consecutive buttons, applying a timer, because usually if you want to say do a dash or a jump back, you can't just press the same button twice. Like you don't just press forward twice, you have to press forward twice in a very short period of time. So it tracks what button has been pressed as well as the time it's been pressed. Other examples would be like if you hold, say, the down button for 2 seconds, and when you let go, you do like a charge attack. And there'll be a few other examples, so we'll see how many we do. And in this project is this tutorial can scale very easily if there's other examples you'd like to see. So all I've done so far is I've just dragged and dropped the images from an external folder into this one, so you haven't missed anything. So let's just start by putting in what's going to be our platform. Just need to scale this out a bit. And we'll push that down towards the bottom of the screen. Second thing we're going to do is we're going to create our player. Click on Add Component. Click on Physics 2D, and we're going to give Rigid Body Component. Everything can stay the same with the exception of Fixed Angle. Put a check on that. That way she doesn't rotate around. Click on Add Component, Physics 2D, and click on Box Collider. Click on Edit, and we're going to shrink it in. It's not a trigger because they need to be able to make contact with the ground. So let's slide them over. So they have the rigid body, so as that physics is applied to them. Box collider, so they can actually collide with objects. Let's go back to that white background, and we'll also add Physics 2D box collider, but no rigid body. We don't need to apply physics to it. So that's the start. Now I've already typed out separately, I'll paste it in one line at a time or a couple lines at a time, the code in a text file, because it actually took me longer to make this work than I thought it would. It's not that bad, it's just you have to check for several different factors to make this work. So usually I try to do an iterative approach. I try to do a little bit, show you how it works, do a little bit more. Problem is, what gets you to say about 90% doesn't get you to 100%. Basically, you have to break it and not start from scratch, but you have to make some substantial changes. So unfortunately, I can't really take that iterative approach because you're going to basically waste your time typing code that you're not going to use. So, click on Add Component, New Script, and we'll call this Hero Control. Now what we'll do is we'll open up Hero Control. And let's begin. So first, outside of start, outside of update, we're going to put in public key code tap left, public key code tap right. Pretty straightforward. This is a keystroke we're going to look for. This is the name of the variable that's going to capture that keystroke. As you can see, it's saying tap left, so that's going to check for a left tap. Same thing for tap right. Actually, let's save it right there, and the reason for that is you will then see the variables appear. See tap left, tap right. We're going to use the typical keyboard control, so we're going to use A for left and D for right. And like I said, as we go on, we can always revise this for, say, a game controller or a touchpad. But once you get the principles down, it's easy enough to swap out the actual syntax. Okay, so as you can see, those two variables gave us the two keystrokes that I'm going to be looking for. if you might have noticed, I try to group these by what they are. You don't actually have to put these spaces in. You don't have to group it, but I think it makes more sense when you see a certain type of variable together. So public sprite, so it tells you it's going to be an image. Dash punch, very self-explanatory. It's going to be her dashing forward, punching. Jump back, that's when she is going to do just that. And idle image is when she's doing nothing or walking. Sorry, I don't have any animation cycles in this. I just have a single image. Handling animation cycles is another tutorial in and of itself. This is just about capturing the individual keystrokes. So when we save that, you're going to see those three will appear now. So dash punch, jump back, and idle image. The idle image is the same default image, but since we have to swap it back and forth, we need to create a variable for it. It's this image here. If anyone knows the code to refer back to this image, great, let me know in the comments, but I don't know how to, so it's easy enough just to create a new variable and drag and drop it there. I can't imagine it really impacting memory or performance because it's a 2D game. Dash punch. Okay. And actually, let's go ahead and add one more. Let's call it public sprite. Call it knee attack. This will be what happens when you like press down for a couple seconds, and we'll bring that one over there. So the key codes give us the two keys we're going to check for. The sprites give us the images that we're going to change between depending on what she's doing. Now these are the variables that we're going to monitor to actually functionally decide what's going on. So public int left total, that is a check of how many times the left key has been pressed, because usually you do a double tap, so you have to count it. Public float is the delay, so left time delay. Public int right total, how many times you've tapped right. And public float right time delay, again, is going to track how long it's been since you pressed right. Because if you press right and you wait too long, then the timer should reset and you shouldn't be able to dash. Public int xvel 0. What this is going to be is when we put in the statement that actually modifies velocity, by putting in this variable, we can modify if they're just walking at the normal speed or if they're dashing. We'll save that. We don't have to jump back to the inspector because we already put the values in here. You might need start. We don't, so for demonstrative purposes, I'm going to get rid of it. Now this is going to be a little bit different from what I normally do. Usually I just do one check for a keystroke, but we actually have to check for three entirely different ones, which is actually great because you'll see all three in action. So if input get key is as long as the key is being pressed. So it's basically you use it for rapid fire. So get key, tap right, so if tap right is pressed, get component, rigid body 2D, velocity, +2 plus xvel. So there's that variable I was talking about. It's currently 0, so your character will move at a 2 velocity. Now the next one. If input.getKeyDown, this is the single frame in which the key is pressed down. And in here, what you're doing is you're saying write total is increased by 1 because we want to track if you've double tapped or single tapped. And this just tells us you don't actually have to do this. This is really for troubleshooting, so you actually don't need that. Now the reason why we have to do this is because, like I said, this is ongoing. So if we put this in here, every single frame the number is going to be increased. We don't want that. We want it to be increased just once when the key is down, because like I said, get key down is just the single frame that the key has been pressed, whereas this is true as long as the key is continually pressed down. So since we only want it once, we got to check for when the key is down. Maybe there's a way to do it here. I just couldn't get it, so it's easy enough just to do that. Next one. If input.getKeyUp. So now you've seen all three. You see if the key is being pressed, just the frame it's pressed down, and just the frame that it has been released. Now the reason why we have to check for this is if you let the key go, you really want your character to stop moving. Okay. You want, well, actually two things. This is just the sprint factor. So if you let the key up, then you shouldn't be sprinting. This still is 0, so it might look a little bit weird here, but as we progress, you'll see where this actually gets increased above 0. So my apologies, just bear with me when we get to that. Get component rigid body velocity 0, 0, 0. Technically, you can go without this, because what will happen is as soon as you've let go of the key, get key up, velocity will be dropped to 0. You don't have to do this. If you want your character kind of slow down, maybe they're on ice, maybe they're whatever, they're on for some reason they shouldn't come to a screeching halt, then you could actually just do away with this, and since gravity is applied, the friction between the character and the ground will actually slow them down. Like I said, I normally would try to demonstrate this, but you have to break it to make the thing work in its final state. So just take my word for it that if you didn't do this, the velocity, it would slow down its own, but it would like drift, just like a real object slowing down because it's on a flat surface. Okay, so get component sprite render sprite idle image. That's this. So it starts as the idle image, and you see us saying, okay, change it back to the idle image because you've let the key up. Makes sense, but you haven't seen us change it to the charged image, so it might seem a little weird there. So as we progress, it'll make more sense. Now this is where we start doing the checks, and this is where it got a little bit tricky. So if double open parenthesis write total is equal to 1, double equal sign, and actually let's see if I can zoom in a little bit. There we go. Sorry about that. So if write total is equal to 1 and write time delay is less than 0.5, now this, you're saying, why are you checking this? We haven't done anything with it. We're about to. So if this is equal to 1 and the delay is less than half a second, then we want the write time delay, which starts off as 0, write time delay 0, to have time.delta time added to it. So if you ignore this for a minute, what you're saying is, okay, if you've tapped once, which is here, get key down. If you've tapped once, then let's start the timer. Time.delta time is just how much time has passed since the last frame. So what you're doing is you're now looking at a running cum. You've heard me say that before in my other videos. You're now doing a running tally of how much time has passed since you've pressed this. So you get key down, turns this to 1. This now says, okay, start tracking. If it's less than half a second, then keep adding the time. If it's not less than half a second, then the next statement, which you're about to see, will then reset it. And that would be this one. If write total is equal to 1 and write time delay is greater than or equal to 0.5, then a couple things. and as you see, you need the brackets here since there's more than one line. Technically, you could put brackets around this when you don't have to. Best practice is to surround it by brackets. I just didn't. So if you've pressed the button once and more than half a second has elapsed, then the time delay is being set back to 0. But more importantly, well, this is important too, but more importantly, the write total has been put back to 0. In other words, if you tap the button once, if you don't tap that button again in half a second, it erases, it resets that counter, because you're forcing the player to have to do a double tap. Now, in some games like MMOs, if you press like a certain button, like page up or something, it puts you into auto run. That's not what we're looking to do. This isn't a single press to do a run. This is a double tap to sprint for so long as that button is held for that second tap. Almost done. If write total is equal to 2, so you've now tapped the key a second time. If write total is equal to 2 and the delay is still less than half a second, so that's the running queue that starts once you press it once. So you've pressed it a second time, half a second has not passed since the first time, X velocity now gets increased. So that's where this only matters. So from the very beginning, it's 2 plus 0 whenever you're holding the key down. Now it's 2 plus 2, and so it's a dash because now you're going twice as fast. That's why you have to reset it here when you let the key up. That way this comes back to 2 for the next time you press write. So xvel is set to 2, and since you're dashing, your write total needs to be set back to 0 because you've reset the dash counter. And this is going to change the image, so they're doing the dash punch image. So get component sprite renderer sprite dash punch. So in other words, I want a component of the object that the script is attached to. What component? I want the sprite renderer component. What attribute? The sprite. And what part of that sprite? I want to change which one it is, because you also could change color and things like that. Almost done. So that was if write is equal to 2. And then this is the last portion. And like I was saying, that you can get like 90% there by doing like just the double tap and not check for the timer. But then once you've done the double tap, not having the timer means you basically can tap as slow as you want, as well as the housekeeping needs to be done to reset the dash. Alright, so if write total is equal to 2, so it's mirroring this one, but the time delay has exceeded or equal to half a second. So xvel is set to 0, write total is set to 0, and time delay is set to 0. In other words, you're setting everything back to its defaults. You're not getting a speed bonus. You haven't tapped at all. It's treating as if you haven't tapped right, at least for the purposes of sprinting. And the write time delay has been set back to 0. So let's go ahead and save that. Let's run it. So if I press D and I hold it, I move. Okay. If I tap D but not really fast, I move and then stop. But if I tap D twice within half a second, now you dash. You let go, changes back the original image, and if I press D again, back to the default speed. So the last little bit for this will be to limit how long they can dash. So that's just a matter of adding another couple variables and then resetting them based on time. So let's look at public float dash duration. So that equals 0. So having x velocity, xvel is really the indicator that you're dashing. So rather than having like a separate yes or no variable, what we can just do is if xvel equals 2, so if xvel equals 2, then what we can do is we take that new variable, dash duration is incremented plus equals time dot delta time. If dash duration, let's put it at, oh, say 1 second. If dash duration is greater than 1, then we set xvel to 0, and we set dash duration back to 0, and just to make sure nothing else breaks, we'll reset these back to 0 just as if you had let go of the button. So the amount of times you've tapped right and the delay. So let's see if that's really all it takes. So I'm going to double tap. She slowed down, which is great, but didn't change the image. So that's just a matter of taking this. So we're duplicating the statement that says go back to the idle image. Perfect. Yep, looks like it didn't break it. And so that easy to add a timer as far as how long you can dash. Okay, so that should be about it for this video. Like I said, it was a bit more than I thought it would be, so I'm going to do the other videos separate but built on top of this code, like the double tap to jump back, the hold down to charge an attack, and we'll just build right on this code because we're going to have to actually make some changes for the other things to work. So that's about it for this one.